Now we move on to oxides of nitrogen. So these only occur when you have very high temperature combustion. So in spark ignition engines or petrol engines, this happens. A little bit of the time it also happens in diesel engines, and sometimes in gas turbines for when you have power generation and things like that. The main mechanism for this is called the Zeldovich mechanism. Now don't worry too much about the chemistry of this. This is just for completeness. So N2 breaks up to give you NO and N, and it bonds with an oxygen. So that's the first step. These N's can also bond with oxygen molecules to give you NO and another oxygen radical here, so just a single oxygen atom. And also these N's can bond with OH, which are present in flames, to give you NO plus H. So these are the three main reactions that happen with this Zeldovich mechanism, and you can see they all kind of produce NO. And so that's bad, because these are the NOx that we're not very happy about. And these mechanisms are very, very strongly temperature dependent. So a high temperature will have this happening really, really fast. A lower temperature will have this happening at a much, much slower rate. So that kind of tells you what we should do about this. Lower the temperature, and then we kind of eliminate this as a problem. So because a spark ignition engine can get very high burning temperatures, we can use a catalytic converter. We have to use a catalytic converter because the temperatures are so high that we produce a lot of these NOx, so we have to deal with them. So we put in a catalytic converter. It's called a three-way catalyst, and it gets rid of most of these NOx emissions. We can't really deal with it as well in a diesel engine, but it's not too much of a problem because the temperature is not as high. So that's still, we deal with it by recirculating the exhaust gas, and that will lower the temperature. But we'll talk about that in the question segment. So to oxides of sulfur now. This is for once not car related, and it's mostly produced by the combustion of coal. Okay, so coal here, we use coal to make electricity. It's what we've done for hundreds of years, and it's what we're going to continue to do, I assume, for hundreds of years. So because it's cheap. So that's what coal is all about. And brown coal is particularly bad. It's the worst one. So there's two types of coal, brown and black. Black is very, very good quality coal. It's basically all carbon. Brown coal has water and sulfur and other things in it. That's why it's not all black. And the sulfur in it is particularly bad. So in Victoria, they use a lot of brown coal, and so they really need to pay attention to their sulfur emissions. Otherwise, you could have situations like acid rain happening, which is bad because they contribute to acid rain. So what we do is we usually deal with them by scrubbing the exhaust cooling tower of your power generation plant. So we scrub it with chemicals, and then that takes out all the sulfur, which works quite effectively. And carbon dioxide. So this is the hardest one because carbon dioxide is the major pollutant in combustion. Now we can't control it because this is the product that we actually want. When you burn something, you want to get carbon dioxide out because that means you know that you've used up all the energy. But at the same time, carbon dioxide is a problem. So we're actually stuck in a situation where we can't really do much about it. So what do? We know it contributes to global warming, or we at least suspect it contributes to global warming. So what can we do if we're going to continue using combustion? Our only solution really is to move away from fossil fuels. We don't really have any other solution other than that. Carbon sequestration, so taking carbon dioxide out of the atmosphere and pumping it down underground, not really a feasible thing from my point of view. I don't see that as something that we should pursue too much more. So we really need to just transition away from this. So what are our alternatives? Well, could this mean we could use biofuels? Could we see more electric cars being produced, put on the road? Maybe with renewable electricity. Who knows? Only time will tell really on this one. We really don't have the technology in terms of transport yet to really deal with this one effectively. In electricity generation, yeah, we can deal with this pretty well. We have renewable energies, wind, solar, all that kind of stuff. We can deal with that, but with transport, because we need that really dense energy fuel, we may have a bit of a situation where what do we do with transport? But so that wraps up today's lesson on the pollutants of combustion. So what comes out of combustion that we don't like, and how do we deal with it? So we talked about all of them. So incomplete combustion products, NOx, SOx, and carbon dioxide. And so hopefully you've learned about what really is going on when we burn fuels in our everyday life.